Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question lost more marks than any other on last year's AQA higher paper. A triangle question where students chose the wrong rule and lost method marks. Sound familiar? If you pick sine when you needed cosine, you end up with algebra that can't be fixed. Today I'll give you a tiny routine that stops that mistake in its tracks.
Promise. In the next 12 minutes, you'll learn the single decision flow that tells you which rule to use. 2 clean worked examples, one for the sine rule and one for the cosine rule, and the exact method evidence examiners look for, so you get those method marks. Plus a 10-second check you can do under pressure.
The concept: start with the knowns. If the question gives you 2 angles and one side, ASA or AAS, use the sine rule. If it gives you 3 sides, or 2 sides and the included angle, SSS or SAS, use the cosine rule. The reason is simple. The sine rule links sides to sines of opposite angles, and the cosine rule links sides and the cosine of the included angle. It's a direct extension of Pythagoras when the angle isn't a right angle.
Quick intuitive why. For the sine rule, imagine dropping a perpendicular from one vertex. The height relates to sin of an angle, and those heights give proportional relationships between sides. For the cosine rule, think Pythagoras. A squared plus b squared minus 2ab cos c equals c squared. When angle C is 90 degrees, cos C is 0, and you get Pythagoras back. So cosine handles the general case, where the angle sits between the 2 known sides.
Worked example. Sine rule. Question. In triangle ABC, angle A equals 30 degrees, angle B equals 50 degrees, and side A equals 8 centimeters. Side A is opposite A. Find side B, the side opposite B. Step 1. Label. Write A equals 8, A equals 30 degrees, B equals 50 degrees. Step 2. Choose rule. 2 angles and a side, sine rule. Write the formula. B divided by sine B equals A divided by sine A. Now rearrange. B equals A times sine B divided by sine A. Substitute. B equals 8 times sine 50 degrees divided by sine 30 degrees. Calculate. Sine 50 degrees equals 0.7660, sine 30 degrees equals 0.5, ratio equals 1.532, so B equals 8 times 1.532 equals 12.26 centimeters. That is the numerical answer. Give the correct units and round to the required accuracy. A quick note on the ambiguous case. If you're given 2 sides and a non-included angle, the sine rule can give 2 possible angles, one acute and one obtuse. On higher tier questions, you'll need to check which fits the triangle by using angle sum or looking at side lengths. If that happens, explicitly say, acute or obtuse, check using. Examiners reward that clarity.
Worked example. Cosine rule. Question. Find side C given A equals 7, B equals 8, and included angle C equals 60 degrees. This is SAS, so use the cosine rule. C squared equals A squared plus B squared minus 2AB cos C. Substitute. C squared equals 7 squared plus 8 squared minus 2 times 7 times 8 times cos 60 degrees. Compute. 49 plus 64 minus 112 times 0.5 equals 113 minus 56 equals 57. So C equals square root of 57, approximately 7.55. If instead you needed an angle and you had 3 sides, rearrange. Cos C equals A squared plus B squared minus C squared divided by 2AB, and then use arc cosine to find the angle.
Why this works: expanding the square, A minus B cos C squared, plus the perpendicular piece, leads directly to the cosine rule derivation. But for exams, you don't need the full derivation. You need to recognize the pattern quickly and apply the formula correctly. Exam technique.
Here's where the marks are. For a typical 4-mark triangle question, you'll often see M1 for labelling and stating the formula, M1 for rearranging or continuing the method, M1 for correct substitution and calculation, and A1 for the final answer to the required accuracy. So even if you can't finish the arithmetic, show the algebraic step. That's often a method mark in the bank. Remember, the examiner wants evidence, not mental arithmetic.
Concrete exam language that wins marks. Start with, let side A be opposite angle A, or using the sine rule, B over sin B equals A over sin A. That exact wording shows the examiner you know which rule applies. Then show your rearrangement. B equals A sin B over sin A, and finally the substituted line with your calculator value. Don't skip units, and always state the angle units as degrees when you give an angle answer. Common mistakes that lose marks: not labelling which side is which, writing sine or cosine but failing to rearrange, dropping the degree symbol, or giving an angle like 190 degrees. That should ring alarm bells because triangle angles must total 180 degrees. Also watch rounding. If the question asks for 1 decimal place, give it to 1 decimal place, and don't round too early in your working. Quick win. A 3-step decision flow you can say in your head in 10 seconds. 1. Label the triangle and list knowns. 2. If you have 2 angles and a side, sine rule. If you have 3 sides or 2 sides with the included angle, cosine rule. 3. Write the formula, rearrange algebraically, substitute and box your answer. Do a 2-second sanity check. Do the side sizes roughly match the sine ratios? And does any angle sit between 0 and 180? If numbers look off, stop and recheck labelling. 2 10-second checks. First, angle range check. Every angle must be between 0 degrees and 180 degrees. Second, substitute back where possible. If you used the sine rule to find a side, plug it back into the equation b divided by sine b equals a divided by sine a approximately to see if both sides match. That catches around 90% of careless errors. Practice walkthrough, past paper style under exam conditions. Part A. In triangle ABC, A equals 40 degrees, B equals 75 degrees, A equals 10 centimetres. Find B. Step 1. Label. A equals 10, A equals 40 degrees, B equals 75 degrees. Step 2. 2 angles and a side, sine rule. Write. B over sine 75 degrees equals 10 over sine 40 degrees. Rearrange. B equals 10 times sine 75 degrees divided by sine 40 degrees. Substitute. Sine 75 degrees, approximately 0.966. Sine 40 degrees, approximately 0.643. Ratio, approximately 1.502. So B approximately 15.02 centimetres. Show the substitution line clearly. That's M1 and calculator working for M1. Final rounded answer to 2DP or to the accuracy requested earns A1. Mark breakdown for that part. M1 for labelling and stating the sine rule, M1 for the correct rearrangement, M1 for substitution and calculation, A1 for the final value to the correct accuracy. If you forgot to label angle and side, you risk losing the first method mark.
Part B. Given sides A equals 7 centimetres, B equals 8 centimetres, and C equals 9 centimetres, find angle C. This is SSS, so use the cosine rule. Write cos C equals A squared plus B squared minus C squared divided by 2AB. Substitute cos C equals 49 plus 64 minus 81 divided by 2 times 7 times 8 equals 32 divided by 112 equals 0.2857. Then C equals arc cos of 0.2857 equals 73.4 degrees. Again, show the algebraic fraction line and the calculator step. That's method evidence. Box your final angle and state degrees.
In that cosine example, you pick up M1 for writing cosine rule, M1 for substitution and simplification, and A1 for the final angle. If an arc cos gives a value close to the boundary, mention you used a calculator in degree mode, a small note that examiners like because it explains your method. Final recap and practical tip. Label, spot knowns, pick the rule. Write the formula in words first, using the sine rule or using the cosine rule, then show the algebraic steps. That's your quick win for today.
If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.